Hey everyone, Davo here with another video. Today we'll be setting up a remote access VPN to our VPC via AWS VPN Endpoint in order to gain access to our private subnets without exposing our bastion hosted public internet. So the way this works is we'll be establishing a connection to the VPN endpoint, which is going to be configured with an identity provider set up on IAM, and the IDP will be pointing to an AWS single sign-on custom SAML application, which we will configure ourselves. We can assign single sign-on apps to users or groups in order to determine what subnets will be authorized to access through this VPN client endpoint. So the way this works in detail is we'll send a request to the endpoint. The endpoint is then gonna look at its configuration. It's gonna send us over to the single sign-on application to log in, and we'll get a SAML token in return, which we will send over to the VPN endpoint, which will then verify the validity of the token with single sign-on application. Will be put in on a VPN subnet, and we'll be able to tunnel in through our private subnet. So to start off, let's head over to the single sign-on application or the single sign-on module, and we'll create a new custom SAML application. We'll go ahead and name it VPN Access, and the description can be the same. The only thing we need to download is the metadata file, which we will then upload to our identity provider configuration on IAM. Let's set the session duration to 4 hours, and we need to look at the documentation for some of these values. We need to define the consumer service URL or the assertion URL, as well as the audience URI. So let's bring these values in. I'm gonna link the documentation to the description below. Looks like I have an extra space down here. Let me clean that up. This one looks good. Let's go ahead and save changes. Now that we've configured or set up the application, let's go ahead and define what users or groups can access or connect to the VPN. So I'm going to add myself, and I'm going to add an admin group here. There's another setting that we need to configure, which are the mappings, and this is where we define the values that we map between the single sign-on user attributes to the VPN service attributes that are required for the connection. So we have a mandatory field for the subject that SSO needs to define, and we have 4 other attributes that are required for the VPN. So we have name ID, which should map to an email address of the user. We have the first name, the last name, and any memberships that the user may have. So let's set all these formats to basic, and now that we have all the attribute mappings in place, let's just review the configuration. Everything looks good. So now we can go ahead and create our identity provider through IAM. So let's go to IAM, identity providers, and let's create a new provider. And this is where we upload the metadata file that we downloaded from the single sign-on application. And that's all the information we need. And there it is. So now let's head over to the client VPN endpoints. We'll create a brand new VPN endpoint. We'll call it VPN Access. We're going to define the subnet where the VPN users get assigned to. Let's define our SAML provider, which is the one we just created through IAM. For DNS, we need to put in the default DNS service provided to us through the VPC. So that's the second IP on the VPC. And let's go ahead and select other default values and submit. And now we have to associate subnets to it. I do happen to have a public subnet on this VPC. Let me just check real quick what the subnet ID is. It's this one right there. Copy, paste in there. It does need to be a public subnet because this is where the endpoints are going to be attached to, and the endpoints need to be reachable through the internet. So it needs to be a public subnet. So it creates a default route table for us. So as long as we connect to the VPN, it's going to add a 10 or whatever your VPC subnet is route. Let's go ahead and create a new authorization rule. This defines who can access this subnet to begin with. So for testing purposes, I'm just going to add everybody. You could define a group, and that would be the single sign-on group ID, not the name. And let's go ahead and download the client configuration file. It takes a while for the VPN to get started or to get created. It takes about 15 minutes. So while that gets created, I'm going to import the VPN profile into the client. And let's just wait until the VPN is established or endpoint is created, which is done now. So now we go ahead and test the VPN. It redirects to a single sign-on. I'm already logged in. So this is the authentication already being successful and the token being sent to the VPN service, which is then going to validate the SAML token, which takes about 5-6 seconds or so. And now we're connected. So now we should be good to try to connect to our private subnets. So let's get the IP of this EC2 instance that I have. We're going to try to ping it real quick. Ping is successful, and just as you would expect, we're also able to SSH into the system. So there it is, a very quick and simple way to provide secure access to private subnets or even to jumpboxes or bastion hosts on public subnets as well. All VPN users will share the same public IPs from the client VPN endpoint, so you can use that to whitelist certain applications to only be accessible to your VPN clients, things like test or staging environments, for instance. You can use pretty much any identity provider as well. In this video we used AWS single sign-on, but you can replace it with Google Apps, Okta, AD, or any other pretty much. So I hope you liked the video, and I'll see you guys in the next one.